May I say immediately that I'm very, very glad that I'm not actually in charge of your IT system here tonight. Because if I were, this would not be working at all. So thank you very much, Dan. It's a huge pleasure and a privilege to chair a meeting by the Newcomen Society, and even more to chair a talk by Justine Bayley. Now, I have known Justine Bayley through her work as the editor of the Historical Metallurgy Society for some 10 years now, submitting very poorly finished papers to her for improvement and having them brilliantly improved. I assumed that anybody who was editing a newspaper, editing a journal would have to be probably an arts graduate, but I discover that Justine, in fact, has a degree in physics with some chemistry, which she obtained from Sussex University, which explains why she was able to correct some of the arithmetic in my papers, for which I'm very grateful, Justine. It would have been a huge embarrassment to have miscalculations in my papers. I mean, Justine also has an MSc in archaeology and has done a PhD in Roman and medieval metalworking over the years. The first at University College London, the second as an external London University qualification. But she spent most of her life working with English heritage I think for the most of the time in charge of the technical aspects of the work that that English heritage were doing. And she has accordingly got a pretty good grasp of all the necessary archaeometallurgical techniques. Her particular subjects that she's researched alongside running the unit were all to do with Roman and medieval metal and glassware works. And she's, besides editing the Historic Metallurgy Journal, she's been editing a very large number of periodicals and brochures for English heritage. She retired from English heritage in 2010, but remains a senior honorary research associate at University College London. A subject tonight of early industrialisation is particularly pertinent to me because my subject is really, pre-industrialisation. My subject is early industrialisation. So they should mesh together. I'm very excited about that. So I'm particularly looking forward to hearing Justine talk.
I hope that you won't be disappointed by what you hear after that very generous introduction to you. I've put this picture on to start the evening because if we go back to the early years of the Middle Ages, maybe around the 10th century, that sort of time, a lot of your craftsmen were itinerants. They would go around to where the work was, and you effectively have one man and his dog being the unit. This is definitely not industry as we know it today. And so how do we get from this early small-scale crafts working to the Industrial Revolution? And is it a baseline and then suddenly everything changes? No, what I'm going to try and persuade you tonight is that it's a gradual increase in industrialization as we go through the Middle Ages and into the early modern period. So if we start off by saying, what is the Industrial Revolution? I'm sure as Newcomen Society members, you're all very well aware of this. It begins in the 18th and 19th century. It's got some earlier origins, but a lot of the industries that you think of belonging to the Industrial Revolution, they've got changes coming in the 16th century, and for some of them even earlier. And before that, you've got craftsmen making things by hand, but even in that small scale industry, you've got some changes coming in through the whole of the medieval period. We look to begin with at pre-industrial craftsmanship. It was one man on his own, a woman on her own maybe, or a small group of people making things by hand. Their tools were all hand operated. There was a lot of conservatism in the techniques they used. It was the sort of old-fashioned, if it ain't broke, don't try and fix it. But the designs of the objects that they were making certainly changed radically over time. There was little incentive really to experiment. What happens if I do this rather than that? That is really something that comes with the Enlightenment in the post-medieval period. Yes, there are innovations that come earlier, but it's not usually because of what the craftsmen are doing. Sorry, thank you. Yet one more person come to listen. The other thing I think to think of is this early period, time is cheap and materials are expensive. So often, even if you're selling very intricate metalwork, for instance, you will sell it by weight. That's the weight of the material that went into it, not how many hours it took you to make it. And that's still current in less developed parts, economies in the world, even in the 20th century. So having dealt with the Industrial Revolution, I'm now going to talk to you a little bit about what do we mean by industry. It's using machinery, it's working on a large scale, maybe in a large building. You're not just using manpower, you've got other sources of power. On the scale of working, you're producing lots of identical products. You maybe got many workers there, all doing or doing different stages in a chain of production. And what I'm going to be showing you is really evidence, mostly archaeological evidence, for this happening and starting to happen way back in the Middle Ages rather than at the beginning of the Industrial Revolution. So the source of evidence I shall be presenting to you are mainly archaeological. They're evidence from excavations of features, the finds you produce or that come out of the ground. So you've got evidence about workshops, about furnaces and hearths, raw materials and tools that were being used. And you'll often find a lot of the waste products, which you can then investigate using scientific techniques to identify what process or processes were being carried on. There are medieval and Renaissance technical treatises, well known, well, luckily, from my point of view, available in modern translations, translated by people who understand the technology, not just by linguists. And that gives us an extra layer of information we can use to help interpret the archaeological finds. There are some other documents I've listed here, things like wills and guild records, but I've not made much use of those. This is a very sensitive thing. Go back. Right, I'm starting off with ironworking, the bloomery process, which is the medieval and prehistoric in a way of making iron, very small scale. Now there should be another picture here, but I don't know. I'm probably dicing with death trying to get that up as well. Yes, here we are. So on the right, you've got a replica furnace that's been built. It shows the sort of scale you're working on. You've got probably 2 or 3 people there, and they're producing iron. You're roasting your iron ore. You're then putting the roasted ore with charcoal into a furnace. The iron oxides are reduced to metallic iron, but in solid state. And what you end up with is a slag liquid, which will be tapped out, an iron silicate slag, and then iron metal, a bloom, which is a sort of sponge of solid iron with some slag trapped in it. And I'm sure we're not quite really right. A development of the medieval period here, you've got water power coming into play. You can use it to power the bellows, and it allows you to produce larger blooms. You've got a more constant draft. You're increasing the scale of the operation, and the water power, of course, can also drive a trip hammer to consolidate these blooms. And this is old data from back in the 60s that Ronnie Tarcoat put together, showing how the sizes of iron blooms increased with time. You can see along the bottom, you're starting off prehistory, and then you've got a sort of plateau through most of the medieval period. And then suddenly, towards the end, he's detecting much larger blooms being made in the 15th and early 16th century. And this is when water power comes into play in a major sort of way. Yes, I have a wheel of death here. Right, so if you've got water power, this is a reconstruction drawing based on archaeological findings at borders of the Abbey, which is in the West Midlands. And it's an early smithy. It's not water power here being applied to a furnace. It's for the smithy. So once you've got your bloom, you take it out of the furnace, you've then got to consolidate this iron sponge. And so having a hammer, having a large fire, water-powered bellows makes it much easier. You can work on a much larger scale than you otherwise could do. Here's another example from slightly later. These illustrations are of a 16th century smithy, but water-powered again. If you look up to the top right there, the plan, H is your pond, the water that's been ponded up to drive the wheels, the dam, G, and then you've got various water courses coming down with wheels in them, which are driving the bellows, and you've got 2 furnaces there, A1 and B1, that are being powered that way. So this is not water-powered smelting, this is water-powered smithing. It started in the end of the 15th century. This is, as I say, 16th century, and it finished in the early 17th century, but the waterworks went on to blow in a blast furnace, which was nearby, was built at the end of the 17th century. So this sort of reuse of infrastructure, again, is something that comes in, having built something on an industrial scale, I would argue, it then continues on in use. And here's an illustration of an early blast furnace, this one from Netherlands, but very much the same as ones I'll show you in a minute from this country. But you can see the scale is quite different. If you remember, I showed you a bloomery furnace that was, you know, the whole structure was maybe a couple of meters across. Well, look at the people here. I mean, that's telling you this is an absolute step change. You're still using charcoal as the fuel. You can see the water wheel to the left of the furnace there, and you've got either iron metal being tapped out. This is liquid iron you're producing, what we now call cast iron. And you've got other stages, though, of the process illustrated here. Down in the foreground to the right, you've got people sifting through the roasted ore, and then they're carrying up in baskets to tip in at the top of the furnace. So, I mean, this is a change in iron smelting, but it's in the 16th century. It's well before the Industrial Revolution. And here's, if you like, English archaeological evidence for it. The structure you can see at the top right is the base of an early blast furnace from the mid-16th century. You've got English blast furnaces coming from right the end of the 15th century, just before 1500. And then this is one of the sort of mid-16th century ones. The plan to the left there probably is rather clearer, easier to see than the actual photo of the excavations and the features it found. You can see you've got the hearth, the working part of the furnace in the center. You've got the bellows to the right, which are driven by a wheel in the wheel pit down at the bottom there. And the water, in this case, is coming from the other direction, from the one I showed you just now. The dam is to the right of the furnace. You've got the water flowing down, turning the wheel, blowing the bellows, and this is bellows blown smelting going on here in the 16th century. This site, incidentally, there was a water-powered forge earlier on in the 14th century. So again, you've got the reusing the infrastructure once it's been produced. And the products, bloomeries, they produce malleable iron. It can be plain iron, it can be phosphoric iron if your ores are phosphoric, or it can be steel. Blast, which is iron with a small amount of carbon in it. Blast furnaces, they produce brittle cast iron, much higher carbon contents, at least several % of carbon in them. And sometimes objects were cast direct from the furnace, but usually they were cast pigs, and then they would remelt those and cast in a rather more controlled way away from the actual smelting furnace. And you could refine this iron to make malleable iron, to make everyday objects, things like knives and nails and bits and pieces like that. So if we compare these two iron smelting technologies, your bloomery furnace, which has been going for thousands of years, 2,000 years anyway, you're working at a relatively low temperature, you're producing solid iron, iron silicate slags, and you've got hand bellows or water-powered bellows. You're burning charcoal as your fuel. And compare that with the blast furnace, it's working at higher temperatures. You're producing liquid cast iron, you can tap that out of the furnace. And you're producing calcium silicate slags because you're putting limestone as well as the iron ore in at the top of the furnace. And this means that all of the iron virtually that's in the ore comes out as metallic iron. Whereas with your bloomery furnace, you've got an iron silicate slag, and so you've got to have a very rich ore before it's going to be smeltable. And blast furnace initially, the period I'm talking about, it's charcoal fueled, but then you get coke being used as the fuel. But that's a development from, after the period I'm looking at. But I'm just using this as an example of how technologies really develop and get larger in scale, but it's an earlier period, certainly well before the Industrial Revolution. If we look at small-scale ironsmithing, making small objects, it's a rather different story. This is a 14th century illustration. This is a 16th century one. This is a 20th century smithy, and you'll see exactly the same features in all of them. This is one off, if you like, 1, 2, 3 men working, hand-blown bellows, keeping the fire going. In the top picture, you can see at the far right, man holding the workpiece. He's the boss. He's got a small hammer. He taps on the workpiece where he wants his assistant with the big heavy hammer to hit. You've got exactly the same thing in the picture below. Nothing has changed here. This is continuation, if you like, of small-scale craftsmanship, which goes right through to the present day. But there are some large-scale ironwork that's produced in the late medieval period. This is an early 16th century cannon from the Mary Rose, but there were similar cannon being produced as early as the 14th century. And this is made out of wrought iron. It's made like a barrel. You've got staves, long strips of iron that run along the barrel, and then you have hoops which you heat up, drop over the barrel, and as they cool, they hold the staves together. And this was the way that you could make a workable piece to fire, but without casting it all in one. And in the 16th century, middle of the 16th century, you begin to get cast cannon. Seemed to be an English speciality to begin with. The Weald was the place where most of them were made, and really nobody else was having a go at it until the 17th century. And these pictures, they show you the cannon from Pippingford, excavation by David Crossley, and it's there, it's still got its casting head on. You can see up at the top of end of the cannon. And this, it's never been cleaned up, it's never been used. Why? Because they would have tapped it and found that there were voids, the metal hadn't run and totally filled the mold, and so it was useless. They could have melted it down again, reused the metal, but they didn't do so. And what you had to do with these castings, although you got a core in the middle, you had to ream that out and make a nice broad casting. And this is Beringuccio's instructions how to do it. The big wheel on the left there would be powered by 2 men walking round it to turn the drill bit that comes through and opens up the cannon. And here is a drill bit that was found at Pippingford. So we've got all the stages. We know they were doing it. This isn't just one man and his dog in a smithy having a go. This is iron casting, large scale. And I think it's, you know, the beginnings of the technology that then goes on to produce large iron cauldrons and things like that in following centuries. If we leave iron behind, I've said quite enough about that. Look at lead smelting, and that again is something where you've got changing technologies. You start off in the medieval period with a bowl. It's basically a bonfire on a hillside. It's blown by the natural wind. You'll put it somewhere that it'll get a good draft, and you're burning wood, you're reducing the lead, and you're ending up with lead metal, but it's very wasteful. A lot of the metal gets oxidized, you don't retrieve it as metal. And so you get the ore hearth coming in, different process in the something like the 16th century. Here you've got bellows blown, again, either hand bellows or later on water powered. You've got different fuels being used. And it's a rather more efficient process. And then finally in the 17th century, you've got cupola, reverberatory furnace, and you're getting a different technology completely. And why all these changes? You've got increasing temperatures, but you've got increasing efficiency. You're getting more of the lead that's in the ore out as usable metal. And so it's an economic driver for changing the technology, because you're going to get more of the lead that's in the ore out as usable metal at the end. We look at secondary non-ferrous metal working, by which I'm meaning once you've got your metal, be it copper or silver, whatever, you're turning it into objects. And to begin with, these are something like 10th century in date. These are little crucibles used for melting metal. Slightly larger one. These are all to the same scale. That's a 13th century one. And then here are some early 16th century ones. And again, you can see you've got a change in scale of operation. You've still got small crucibles later on when you're making small objects, but you've got the capacity to melt and cast much larger amounts of metal in one go. Other thing you may notice here is the early crucibles have all got rounded bases, and the later ones have got flat bases, and this is because the sort of path they were using has changed. Your early crucibles, they sat in a bed of charcoal. It's much more stable to have a rounded or pointed base. Your later ones, they're sitting on an iron grid in a hearth, again buried in the fire but supported. And so the change in hearth or furnace design is driving change in the form of the crucibles. With your small crucibles, you're going to be casting small objects like this penannular brooch. This is from the late first millennium AD. You've got a two-piece clay mold. You'll pour the metal into it, and one mold, one object. And these molds were throwaways. You don't use them more than once. You'd have a pattern piece from which you make the mold, and that gets reused time and again. But the actual molds themselves were one trip. And you come later into the 13th, 14th century, and you've got the same sorts of objects. These are small buckles being made, but the mold technology has changed. You can see you've got multiple buckles being cast in one mold, up to 50 or so, maybe more in one go. And so this is moving towards mass production. You've got more demand for these small everyday objects. And so you're making them on a larger scale. The molds are still throwaway. You don't use them more than once, but you're trying to produce more objects at one go. And the metalworks top left there are the sort of castings you'd be making. You've then got to cut them up into individual buckles before you can sell them to people. So it's a scale. You're using the same sort of technology. They're clay molds, they're not reusable, but you're manufacturing on a much larger scale, and you had larger crucibles, you could make larger amounts of metal, and so you could make more castings in one go. If you look at bigger objects, things like bells, and this is another case where the technology really doesn't change in centuries. And in fact, if you'd gone and looked at what the Whitechapel Bell Foundry was doing only a few years ago before it closed down, you'd have seen a lot of similarities between this, which is a 10th century bell from Gloucester. Here's a 17th century bell, but its shape is somewhat different, but the way it was made and cast is just the same. And this is how you would have done it. You make your core, you make your coat, the outer part of the mold, you assemble them, bury it in the ground in the bell pit, and then you build a furnace, melt the metal and run it in. And that technology hasn't changed in over 1,000 years. You're making large objects, but in a way they're one-offs, but because of the size of the undertaking, you're probably going to have quite a number of different people involved in the preparation of the mold, building the furnace, running it all. And so I think this is a more industrial level of production, even though each product is a one-off. If we think about wrought metalworking, a lot of that is, again, small scale people fashioning objects, brooches, buckles, decorative knobs you fit on your belts and your clothes. But that's, again, a small scale working that an individual craftsman or his family, or maybe him and an apprentice, would work on their own. But we have to remember that some classes of objects were actually made in very large quantities, even in the early medieval period. You know, there are thousands and thousands of coins produced. You know, they're still found in large hoards. And so we know, you know, the production was enormous, but we still think of it in terms of, here you've got a group of men producing coins. At the left there, you've got somebody hammering out strips of metal and then cutting out blanks from them. Man next to him with the hammer above his head, he's striking the coins between two dies. And chap third along, he's showing the bosses, you know, is this what you wanted? Is that do, the right sort of quality? And so you've got lots of people working at different stages of the production. And I would argue that this is moving towards industrialization. You've not got one man who is taking a lump of metal and ending up with a coin. You've got lots of different people doing different stages in the process. And why have I concentrated on coins here? Well, moving on to talk about what I'm describing as chemical metallurgy. This is low temperature metal processing. And the examples I'm going to give you all come from the Tudor Mint at the Tower of London, which is why coins were a useful introduction to it. This is a drawing from Urquhart's textbook, if you like, of the late 16th century. This is what a good workshop should look like. You've got all sorts of things there. You've got at the back a pair of furnaces, some crucibles. Here in the foreground, you've got distillation flasks. They would have been being used for making nitric acid. And at the back in the other room, you've got an assay furnace for testing the purity of precious metals. So if we look at each of these processes in turn, looking at the Tower of London as an example, this is a plan of, I think, 1597, and the area I'm interested in is here, Legs Mount, the northwest corner. And this, I mean, now it's got emplacements on the roof, all sorts of things, but at this point it was just a shell bastion. And if we zoom in on that, you can see you've got two houses there, just ordinary houses, but the streets on either side, the area that's labelled D, down bottom left, and F up at the top, those are all described in the caption as being part of the mint. Or, you know, this was the assay master's house. So that whole area in the outer part of the Tower of London in the 16th century was occupied by the mint. In fact, there were two mints in the Tower at this period because they were having to clear up the mess Henry VIII had made by debasing the coinage so dreadfully that didn't have enough silver in it and nobody would accept the coins. So they were bringing back all the old coinage into the mint, refining it down, extracting the silver from it, and then issuing good new coins. And this is excavations carried out on the footprint of where those two buildings were in the previous slide. And what you can see here, the red line along the wall, that's the front wall of the workshop. There's a pair of furnaces behind. The curved wall at the back is the shell bastion, the fortifications there, and there's a cellar. And in the fire pit in front of the furnaces were found the crucibles I've just shown you. So you've got a considerable scale of working here. We've actually got a workshop where various processes have been carried out. But this is the beginning of the 16th century. It's not industrialization. talked about distilling nitric acid. Why would you want to do that? Well, this was a new technology. Distillation came from the Middle East, from the Islamic world, which had been taken up in Northern Europe from the 15th century onwards. And these are some of the flasks that would have been used in this way. You can see in the center picture to the right, the flask is about this high, really quite large thing, and it's being into it you put your vitriol and your saltpeter, bit of water, stew it up, then you distill off the nitric acid, and what you're left with is iron oxides, which is why you've got this dark red color on the inside of other sherds there. Nitric acid you were using for parting. If you've got a mixed gold-silver alloy, there were old methods, which I'll come to in a minute, for separating the two, but much easier was hammer your metal out fairly thin, dunk it in nitric acid. The nitric acid will dissolve out the silver, it won't affect gold, and so you've separated gold from silver. And this is, you know, a new technology of the 16th century. The old technology, here you have lidded crucibles, or what I describe as parting vessels. This process is known as parting, separating gold from silver. You have, again, your thin sheets of metal interleaved with powdered ceramic and common salt. Heat it up below the melting point of the metal. Salt attacks the silver, you form silver chloride, which is volatile. It's removed from the metal, it's absorbed by the ceramic, and the salt also attacks the walls of the vessel, and you get this very bleached appearance, and then redeposited on it these sort of pink and purple layers, which are, again, specular hematite effectively. So you're affecting the ceramic, but you're also separating the gold from the silver. And that technology goes right back to Roman times, but we've got evidence of it in the Tower of London in the 15th century. In the 16th century, that disappears because they're using nitric acid. It's ever so much easier. The final technology I'm going to talk about here is assaying silver. What you're wanting to do, you've been given some silver, you want to know how pure it is, how debased it is, maybe the question should be. And so what you will do, you'll weigh a small sample, you'll put it in a bone ash cupel with a lot of lead, a surplus of lead, an excess of lead, heat it up. The lead will oxidize in conditions, lots of air blowing over it in the furnace, and the lead will oxidize any base metals in the silver. The lead and the base metals will be absorbed by the cupel, and you're left with your pure silver on the top. And if you then weigh that again, the loss in weight tells you how much debasement there was. And then you can choose, having got your pure silver, how much you are going to debase it back when you're making your new coins. This process is just a testing, it's an assay. You'll do the same thing on a much larger scale in a half, it's maybe this sort of size, working with much larger quantities of silver, but I don't have evidence of that from the Tower of London. So, leaving metals to one side, we'll have a quick look now at glass working and some of the innovations that come in the late medieval and early post-medieval period. This is looking at the Weald, the Western Weald in Surrey, Sussex. You've got glass working there from the 14th century, and the nice model at the bottom comes from the Science Museum, based on excavations that were done in the 60s. And this is, if you like, the plan and section that was produced from the excavations that was used to make that model. And this is another glass furnace, not from the Weald, this is from Staffordshire, where there's also quite a lot of glass working on Cannock Chase in the 15th and 16th centuries. And you've got the same sort of structure here. You have these long walls, if you like, on either side of a fire trench. You set the fire from both ends. You're burning wood here, not charcoal. You've got pots, open crucibles sitting on these things, these walls, which are described as sieges, and then you will dip molten glass out of them. And the well-known drawing on the left there shows, if you like, a complete furnace in use. You've got your crucibles inside the furnace with these so-called glory holes, where you can put your blowing iron in, collect the glass, blow the vessels or the sheets of glass, if you're trying to make window glass, that you want. To the right there, you can see there's a heap of something on the roof of a lean-to structure. That's timber that's been dried. This is burning timber, not charcoal. And at the far left end, you can see there's, if you like, a subsidiary add-on to the furnace where the glass is put to cool. It has to be cooled slowly, otherwise it will shatter. If you put a newly blown glass down, let it get cold, touch it, and it will shatter. If you've cooled it gently by putting it in a layer like this, then it's good, it's usable. And up at the top right there, you've got the remains of a 17th century glass furnace, exactly the same type. What you've got there is the dome surviving. At either end, you've got where the fuel was introduced at the bottom, and the walls on either side are the sieges where the pots would have sat. Maybe that the sides were not so strongly built, so that you could get in, get the glass, put new glass into the pots, whatever. Like it's ivy growing beautifully on top, which is probably pulling it to pieces. But now you may say, why is a 17th century furnace of this type unusual? Well, from about 1610, there was legislation which said you're not allowed to use wood to fire your glass furnaces in England. This was in Ireland, so they were able to carry on using the old technology. And this was because in the Weald particularly, there was competition for the timber that was available for furnaces. You've got glass working, you've got iron smelting, you've got cannon founding, all of these different industries, all trying to use the same fuel, and there wasn't enough of it. And so there was a monopoly set up, and there were great changes that came in the very early 17th century. But before that, there had been immigrants from Lorraine that came to the Weald and started making a new type of glass in a new design of furnace. And you have these what are described as winged furnaces. We don't know what they would have looked like in 3D. We've only got the plans, but it's something quite different from what went before, the ones I've just been showing you. And here you're using, initially it's wood in the same way, but this design then becomes altered so that it can cope with mineral fuel, and you're building a fire in the center of the furnace rather than feeding in wood from both ends. And the difference, as well as the difference in the furnace design, you have a difference in the composition of the glass. Your old medieval glass is the forest glass. You've got high levels of potash in it and relatively low levels of lime. The new glass that comes in the towards the end of the 16th century, you've got much higher levels of lime, lower levels of potash. It's a better quality glass. It's more durable. It's usually less coloured. And it was very rapidly adopted. And if we look at changes in glass composition, your forest glass, this old medieval design, I mean, the time scale on that starts at 1400. In fact, this forest glass was used right back from about 1000 AD. So it had a very long period of use. High lime, low alkali glass comes in towards the end of the 16th century. It's only superior product, and almost immediately it completely takes over and you have your new type of furnace to go with it. And then later on into the 17th and 18th centuries and onwards, you've got lots of different normal types of glass being made. But that's not a story I'm going to go into today. That's for another time. And the glass melting crucibles, these pots that sat on the sieges in the furnace, the ones at the top left, those are Roman and Saxon. They're very early on. The ones to the left, the larger ones, they're 14th century. The ones to the right, early 17th century. And by the 18th century, you've got closed pots with a lid on to stop the fumes from the coal getting in and affecting the quality of the glass, but they're over 1 meter high. And if you look, these are at most maybe 1/2 meter. So you've got, this is the beginnings of change of scale, but it goes on and accelerates through the Industrial Revolution. So to finish, or maybe nearly finish, I hope I've demonstrated to you that before the Industrial Revolution, at least some of the manufacturing that went on in this country was on an industrial scale. How do you like to define that? I've shown you examples, smelting metal, minting coins, but even in a single trade, there was no one date where everything changed all over the country overnight. The old technologies often continued in more distant, further away areas, areas where the demand for the product was less. You could carry on working in the old way as you always had done. You've got new technologies coming in, and often they went hand in hand with a change in scale. So whether it was the technology that drove the industrialization or the desire to industrialize, which meant the adoption of new technologies, I think it's very much a chicken and egg question. But despite all of these changes, some processes still carried on in the way they had done for hundreds of years. And really, to just reiterate that, I think in different words, this move towards industrialization, towards the beginning of the Industrial Revolution, the scale of production is increasing, the designs of furnaces and hearths is changing, process technologies, they're responding to economic drivers, you've got beginnings of mechanization, and you've got some new materials and technologies, but the quality of the products didn't always improve with the quantity. And these are all interrelated areas, but I hope you've seen and will believe me when I say industrialization was well on its way before the beginning of the Industrial Revolution. Thank you for your attention.
Well, thank you very much, Justine. Wonderful, just what I was hoping for. But I now have to point out that we're going to have a very difficult question and answer session. Basically, what I am hoping to do is alternate questions between the floor here and the Zoom session, which is going to have to be handled by Dan. So I will ask somebody to give their question. If it's from the floor, Justine will immediately answer it from here. If it's from Zoom, Dan will select and get people to ask the question. So first, if you are on Zoom, if you would like to just give us an indication that you would like to ask a question, then please do that through the chat facility.
Yeah.
So first of all, to make life easy and make people who are online think about it, can I ask somebody from the floor if they have any questions for Justine? At the back there.
Could you come up and make yourself known? The roving mic doesn't seem to be powering up.
Come and have your say.
Right, my name's Lawrence Scales. I thought I heard in most interesting that oak was used for smelting lead before iron. Have I got that right?
I think not. I think the cupola process carried on for a long time into the 18th century, maybe beyond, and it's in its later phases that you're getting coke being used, and it's your more old-fashioned fuels that came now with the start of it.
That's my understanding. Correct.
Yes.
Radical change. Thank
As
you.
far as I know, I have to say.
Well, we don't seem to have anything in chat yet. So another question or observation from the floor?
My name's Fred Starr. As a metallurgist, I know many questions to ask, but it was actually something that you said right at the start, that time wasn't very important in the old days, in medieval times. I'm not absolutely certain about that. One of the things I was interested in as a metallurgist was how much was the cost of materials today. And the cost of materials today comes very much from the cost of energy of production. And that's why plastics are so much cheaper than metals, because they don't require very much energy to turn them into nice shapes. As you go back to medieval times and you think about an arrow as used in Agincourt, how long did that take to make an arrow, even using semi-mass production techniques? And judging from the kind of cost of an arrow in those days, you can sort of tie it in with how much a labourer would have got a week. And you can see that there is a correlation. So time, I think, is money. Would you like to come back to me on that?
I think that you've got a point, certainly, but the materials went into the making all these objects were a major part of their
Oh, well, there again, you know, you showed yourself the picture of three people standing around a crucible making wrought iron. There were three men there. That's a lot of time that they're taking, actually making the shape of the thing, getting the iron ore. It all comes back to manpower in the end. And so I do think you can't rule out time as being an expense in making things.
I'm not saying it isn't an expense. I'm just saying I think it is as much. I mean, today we tend to say, well, I've got a broken thing, can I take it somewhere and get it mended? No, it's far cheaper to buy a new one than to get it mended because of the time and effort that go into mending it. And so in today's market, I think time is much more of a factor than it was early on. And remember that a lot of your labour then would have been the small children who were under your feet and the all of those things. I mean, how did you learn to become an iron smelter? Well, you probably sat and you watched your father or your grandfather for 10 years, by which time you knew how to do it. But during that time, you'd been breaking the charcoal up into the right size pieces. You've been, so do you count the child labour as being part of the time that's expended? I mean, I think what I'm talking about is relative amounts rather than an absolute thing, because obviously any craftsman who is working, if he's a full-time craftsman rather than a farmer who does a bit of craft on the side, he's got to earn his living by what he's producing.
Okay, thank you.
Yes, we have. We've actually got 5 questions. We take one in turn. Can I ask Andrew Smith if he'd like to unmute himself and ask the question?
Hi, thanks very much, Dan. Can you hear me?
Yes.
Yeah, very good. A lot of the changes that you talked about, Justine, seem to have been brought to the UK from Europe and even further afield. Was that accidental or a result of policy? And I'm thinking here of particularly William Cecil's policy under Elizabeth of granting monopolies to foreigners who brought in technological innovations. Was that a policy that had existed beforehand?
I don't think it would have been an explicit policy. I think you would have always have welcomed newcomers who had something to contribute. And so I talked about the glass workers from Lorraine who came to England in the later 16th century. They were being persecuted where they came from. They decided they'd find somewhere better to work. The technology they brought with them was an improvement on what we were using. And so they were welcomed with open arms. They brought something with them that was of value to Britain. And so Britain gave them a home. So you have those sorts of exchanges at all sorts of levels. But what has struck me is a lot of the technologies that I've been showing you from the later Middle Ages, for instance, those multiple part clay molds for casting buckles, there are absolutely identical finds from Paris and from Prague and from Milan, all at the same date. Now, where the idea originated, who did it first and where it traveled to, I don't know. I can't believe that for a technology that ends up with identical looking tools, if you like, if you consider the mold a tool, I don't think it would have been simultaneously invented in 4 different places over a very short period of time. But our dating archaeologically isn't good enough to say which came first. We haven't got any records that deal with those sorts of technological developments in enough detail to be able to identify what's going on. So at the moment, it's still an open question, but certainly I think in Northern Europe, technology was very much the same all over the continent from the Middle Ages onwards.
Thank you. Yeah.
I've been naughty, just make an observation. There's an interesting example of the conflict between shipbuilding and other processes just down the road from where I live. A place called Pett's Wood, which was granted to Phineas Pett, who built the Sovereign of the Seas. But there was an Italian glassmaker called Verzolini who came in the same similar period, and he was granted coppice land for his glassmaking process a couple of miles away, but he had to take coppice wood, not timber.
Coppice wood is what would have been much more valuable if you're using it as fuel, because if you've got a tree that's this diameter, by the time you've split it up into billets that you can put on your fire, it's a lot more work goes into it. Managed coppice is something that, it's been identified in the Roman period up near Carlisle. We know in the 18th, 19th century, there are managed coppices all over the country. And you go and look at some of our historic woodlands and you see these trees that it's been coppice that's let go. And coppice wood is what you would have wanted if you were using it as fuel. So I think they both got what they wanted, for depending on what you're going to do with the trees that grow.
We've got another question from Rob Johnston. Would you like to unmute and ask your question, Rob? Or?
Yes, thank you very much. Oh, sorry, didn't mean to have that at the back of me. I'm quite interested in the way the glass business transposed from being a medieval business to being a modern business. And one of the things that occurs to me is we have some evidence of how their furnaces worked, but we don't have, I'm not sure if they have any records anywhere of how they actually monitored the temperature. And I wonder if you've got any enlightenment for me.
What I can cite to you is there's two people who live near Andover who've built a replica Roman furnace, or in fact several replica Roman furnaces, and have been running them for weeks at a time and blowing Roman style glassware, which shapes wise is all right, it's different from medieval, but it's the same sort of techniques being used. And there you notice the temperature because the working properties of the glass are very different. If it's a bit too cold, you can't pull it into nice threads, you can't, it's just too stiff. If it's too hot, it's too runny, you can't gather it on the blowing iron, it all drips off. So there is quite, the properties of the glass actually tell you what the temperature is, because they're replicas, they were firing it with wood, coppice wood, the sort I was just talking about. And, you know, when they were working, they were saying, oh, well, this glass is getting a bit cool. And so you put in a couple of extra bits of wood into the fire, or else they'd say, oh, no, come on, pull those bits out. You know, it's got too hot. So I think the properties of the glass would have told you whether the temperature was right, rather than anything else. For metalworking, it's often the colour of the metal tells you. I mean, a blacksmith will say, well, that piece of iron, no, that needs to stay in the fire a bit longer. It's not hot enough to weld yet. And that's based on a colour that he sees. And that's why your ironsmithing has to be done indoors rather than out in the open, because you need to be able to see the colours of the metal.
Oh, thanks very much. I mean, are they still active? And if so, do you think I could go and see them?
I saw them back in June, and they were just demolishing one furnace, but we're going to build another.
Okay. If I drop you an email, perhaps you could give me their details.
Yes. So, in fact, if you look on the web, I think they call themselves the Georgian glassmakers.
Okay.
Because they find making replica Georgian drinking glasses brings in a better income than Roman drinking glasses.
Yes, I'm sure. Many thanks.
Right. Tilo Rahane. Would you like to unmute yourself and make your comment? No, I'm just at the wrong distance for either the reading part or the distance part of my spec. Tilo, would you like to ask your question, or shall I read it for you? Tilo asks, can you comment on the transition of wood fuel to mineral coal in glass working in England? Was it a rapid transition or a drawn out process? And what were the main drivers for it? Taxation, regulation, or economics?
The switch from wood as your glass making fuel was imposed on the glass industry and by royal edict, because they were just using up too much of this valuable commodity. And so between, I think it's 1610 and 1620, you go from an industry that's basically wood-fired to one that isn't, that's using, in their experiments, they use the oil shale from Kimmeridge. There's an early furnace there. They're using coal. You've got different styles of furnace which are developed to cope with a different fuel. But it's a very rapid change. And that's why I said this Irish furnace, which was running on the old technology well into the 17th century. I think they could get away with it because they weren't covered by the regulation. And in fact, the king, I think, sold a monopoly to a man called Mansell, who was at the forefront of developing the new technology. And because he had a monopoly, it was worth his while.
Perhaps we'll just go on through the chat, people. There's from a John, but I'm not sure which John. If you'd like to unmute yourself. Yes, we found John.
Hello, it's John Townley. From the description of industrialisation you're talking about, it's not an urban phenomenon, is it?
Your metal smelting is done out where the ores are found, so that's a rural activity. Yep. And your processes that are using a lot of fuel, again, tend to be done in the woods where the fuel is, because it's much easier to cart your product, your cast iron, your wrought iron, whatever, rather than moving lots and cartloads of charcoal, for instance, because if you try and transport charcoal any distance, it gets shaken about, it'll get crushed.
Ends up as dust.
Yes, useless. So in general, where you're using large amounts of raw materials, be they fuel or the raw material for the process will be carried out where the supply is, but your manufacturing of small everyday objects will probably be done where the market is, which is in the towns.
That makes sense.
And when you've got smaller settlements, villages, hamlets, there you'll have your trader, your craftsman going around. The picture I showed you right at the beginning, the man with a knapsack on, with a bellows on it and a dog at his heel, that was how objects got taken to out of the way places for sale. Yeah. Although, of course, you'd have large markets occasionally in towns or near them, and then people from the surrounding countryside would come and buy what they needed.
Thank you.
Right. Next question from Andrew Smith again. Oh, you already asked that one. We've asked one. I seem to have got another one coming up. John Griffiths, would you like to unmute yourself and ask a question?
Hello.
Hi, John.
Sorry, no vision. Bronzes and brasses, how much evidence is there for the production of these alloys in the 15th and 16th centuries?
The pure bronze, as we know it today, a copper tin alloy, is relatively rare in later medieval times. It's used for bells because other metals don't ring in the right way, they don't have the right tone. But most of your everyday objects are made of zinc-rich alloys. Some of them are pure brasses, things where you're, for instance, wire drawing, you'll be using pure brass because it's much more ductile. It responds better to that treatment. A lot of your decorative fittings for clothing, they are not pure brass, but they are definitely zinc-rich alloys. I think probably what nowadays you might call a gunmetal, but in those days they had a range of different names. Maslin was one of them. And your wrought vessels, if you like, your big pans and so on that are hammered out, which become much commoner again in later periods, but you do get them from about 12th century onwards, and those tend to be fairly pure brass being used, again, because it's malleable and you can form the shape that you want quite well. Does that answer your question?
Yes. I have a supplementary question to do with the production of zinc. How widespread was that? Obviously, it depends on the ore source.
And zinc as a metal is not known until the post-medieval period. I think you're talking about probably the 18th century. Your early brass, be it Roman or medieval, is made by cementation. You have your crushed ore mixed with charcoal, mixed with finely divided copper in crucibles, heat it up. The zinc is reduced from the ore. The zinc vapor diffuses into the copper, and eventually you melt the charge and you end up with brass metal. You have to do it this way because zinc it's oxidized. It's reduced at temperatures above which it vaporizes. So if you want to produce zinc metal, you've got to distill it rather than just smelt it and run it out the bottom of the furnace. And you've got early distillation in India and in China, but not in this country. All brass is made by cementation, and the maximum zinc content you can get is about 30%.
Ah, thank you.
So if you find objects with, I mean, that's from the thermodynamics, that as you add zinc, the melting point of the copper drops. And once you've melted your brass, there's such a small surface area through which the zinc vapor can diffuse in that you're not going to take up any more zinc. And that's why you have this value that, I mean, some people say 28%, some people have done experiments and managed to get 31% zinc in a brass, but it's around that. So if you've offered a nice object and you analyze it and it's got 40% zinc, it's not medieval.
It's modern. Very good. Thank you.
It's getting complicated for a technical man. Oliver, would you like to unmute yourself and ask your question, Oliver Piercy?
And start video. Okay. Hi.
Hello
Thanks
there.
very much. Fascinating lecture. Good to see you again. I wondered, I mean, I'm less and less convinced that the Industrial Revolution is actually a thing. Certainly in terms of technological development, it seems to be much more of a continuum. But I wondered how important you rated division of labour. If you look at ceramics production, which you didn't mention, but again, shows all these factors, development well before 1700, often located in towns, where I guess there were the markets, foreign influences, for example, stoneware twice. I just wondered whether you think that it's a bit of an outlier because it was producing objects which were widely used and had subject to fashion as much as anything. But I wondered how far you thought how things were produced in terms of the human organisation was important.
For a lot of industries, I think the answer is we just don't know, because we don't have records that describe the size of the units that were working, producing things. I mean, some of the guild records that survive from large towns talk about, yes, you've got a master and he will have 2 apprentices and he's only allowed 1 journeyman and this, that and the other. So you can talk, you know, reduce, no, maybe not reduce. You get some idea of the size of the unit of people. And certainly a lot of processes you can do on your own, but equally are a lot easier if you've got several people around. I mean, for instance, if you're glass blowing, once you've inflated your vessel, you actually need somebody else to put a punty rod on the end of it so you can crack it off and finish off the rim. And I don't think you can really do that. You know, you can't reach round. So you've got to have at least 2 people, but maybe you've got to have 2 or 3 people stoking the fire or carrying the wood over, or, you know, there are lots of different things. If you're only going to be doing a small amount of working, you can prepare all the raw materials, you can then make things, you then have your product to sell. But if you're going to do it continuously, then you probably need a lot more people involved, because not all the steps will take the same length of time. And so I think it's a very good question. It's maybe something that we should be concentrating on more. But I don't think we yet know the answers, at least not across a whole range of industries. For some, there may be enough detail, but I can't think of any other good examples to give you.
Thank you very much.
I've got a question from Mary Mills, if you'd like to unmute yourself and make your point.
Yes, this was really almost following on from the last question about the sort of codependency of industries on each other and on societal changes. I mean, Danny bringing up Pets Wood reminded me of shipbuilding, because of course the Pets were running some very massive workplaces in the early Tudor period, and making some very complicated things in, you know, huge ships. And I was also slightly later thinking about the Crowleys setting up distribution networks for ironworking, which must have encouraged technological change, but at the same time as everything else, because it's making things in a much larger scale. And that, of course, is perhaps what the Industrial Revolution is said to be about.
I mean, I think you've got different changes coming in at different times in different industries. I mean, one of your supposedly early factory setups was making the blocks for the Royal Navy in Portsmouth.
Yes, that's right.
And I don't know a lot about it. I have to say, metal and glass working on the main industries that I've studied, but I've picked up all the bits and pieces around the edges. There are, I think you just have to say it depends where you are, what you're doing, what the demand is, and in different places at different times, different answers will apply. Sorry, that's really a non-answer, but it's the best I can manage.
It's fine.
Right. We've got a question from John Griffiths about bronzes and brasses. Oh, we've had that one. And then we've finally got an observation from Ray Powell. If anyone, if you'd like to unmute himself and make the observation. Okay.
It's Fred Starr again. It's a pity that Brian Lawton isn't here tonight. He's just written a marvelous paper on the technology of wind power and windmills. And I think this is a very interesting one, because windmills sort of come out of nowhere, and they have continuous development over a long period. And I just like to, it's one of those things showing that people in medieval times were really quite clever and very, very innovative.
Indeed, I would agree with you 100% on that.
Well, I think we've come to the end of questions, and I think probably Justine is getting exhausted. I think the fact that we've had so many is a real show of how interesting people have found this talk, Justine. Personally, I found it terrific, and I've learned a lot, I have to say. I thought I knew quite a bit about that sort of period, but no, I've learned a great deal. So thank you very much indeed. I've been asked to make an announcement about the next meeting, in which John Konevsky is going to talk about industrial steam power in London. That's on the 8th of December. John Konevsky, I'm sure you know, has done an enormous amount of work on the on steam engines in the 18th century, and keeps a huge database of all the engines as people discover them or read about them. So I'm sure that's going to be a very interesting talk. But, if I may, I'll bring the evening to conclusion. And thank you all very much for attending, both here and there, as it were.